All right, so now it's time to get busy and get to work with technical physics. So let me just give you a broad overview of what we're going to be doing here. This is a survey class. For most of you, this will probably be your only time up to bat in a physics course. And let's recognize that most of you are here because it's a required course. You're getting a box checked off, and that's perfectly fine. So my view of this goes this way. If this is the only time you are going to encounter a physics course in your college career, fine, so be it. But let's give you as broad a view of what physics is as we possibly can get done in 16 weeks. So what we're going to do is going to be a little bit different than a College Physics 1 and then followed by a College Physics 2 sort of sequence. This is a one-shot deal. And we're going to put it in the context of human history. We're going to go all the way back to Aristotle, right up to Albert Einstein and Stephen Hawking. We're going to put it in the context of human events. What is physics? Well, physics is basically how the universe works. Now, a lot of folks have some trepidation about a physics course. Typically, it runs along the line of being kind of frightened of the math. It's a daunting proposition, and we have to recognize that. So let me talk about the math just a little bit. First of all, it's not the math that kills a physics student. It really isn't. It's learning the language. The language is the tough part. That takes time because you're going to have to learn a whole new lingo. Now, as to the math, let me just talk about the math part. First of all, I'm not going to require you to memorize formulas. That's foolish, and we have bigger fish to fry. What I do care about is that you're able to use the formulas, that you're able to use the math. What we've discovered over the years is very oftentimes students, for whatever reason, don't walk into a physics course prepared for the math that they are going to encounter. So the first week or so, we're just going to focus on just getting the math down. I'm going to make sure you have all the tools that you need in order to survive this course. And it's not that hard so long as you've got a calculator and you're willing to take the time to write stuff down on a piece of paper. Those are the two critical things. Just be able to use a simple calculator and write stuff down on paper. That's what's going to get you through, at least on the math part of it. The other part, like I said, is learning the lingo, but we'll talk about that later on. Now, like I said, this course is going to go all the way from Aristotle 2,500 years ago right up through to Albert Einstein and Stephen Hawking. And here's a little promise that I'm going to make to you. The most famous equation in the world. I think we all know what that is. There it is. E equals mc squared, the most famous physics formula in the world. So here's my promise to you. If you tough it out and go all the way through 16 weeks, my promise is that by the time we get done with this course 16 weeks from now, you will not only understand what that formula is telling you, you'll be able to actually use it in a problem. What else are we going to talk about? Well, we're going to talk about some of the mechanical stuff. We're going to talk about how things move from point A to point B. We're going to talk about ballistics. We'll talk about how forces work. That sort of stuff. We're going to talk a lot about what Sir Isaac Newton has to say about those things. But we'll also talk about what Albert Einstein has to say about a few things. And that means that we're going to get into some of the sexy stuff toward the end of it. We're going to talk about, for instance, time travel. Time travel is not something that is hypothetical. Time travel is a reality. It is a naturally occurring event in this universe. It's how this universe ticks. Time travel is real. And I'm going to show you how it works and how the arithmetic of it works. And again, it's not that hard so long as you take your time. So we'll have some of that stuff to play with. We'll talk about black holes. And if you can't have fun with a black hole, then I just don't know what to say. But black holes are fun too, so we'll talk about that stuff. But we do have to deal with the arithmetic. So we're going to take it right back to square one. I'm going to do what I call the Vince Lombardi method of instruction. Now, Vince Lombardi, some of you may know, was arguably the greatest football coach that ever existed. And I don't even watch football, and even I know that. Vince Lombardi was a great coach, and a coach at the end of the day is a teacher. Well, here's how Vince Lombardi taught. And remember, for you to have Vince Lombardi as your coach, that means you had to be already a pretty good ball player to begin with. Vince Lombardi didn't care. They'd be in the locker room at the first day of training, and he'd reach down and he'd pick up a football and he'd say, "Gentlemen, this is a football." And then he would teach them from there. So that's how we're going to approach the math problem. Now, you might already be a math whiz, and if you are, well, then relax, sit back and enjoy an easy A. And still, I might have a few tricks up my sleeve that you might find useful. So we're going to start right from the very beginning. Page 1 in the workbook, scientific notation. This one is a perennial bugaboo for a lot of students because typically it's really glossed over in the public schools, and the way it's taught is not something that is generally very useful. Well, we're going to need to be able to use scientific notation effectively. So what is it? Well, here it is. Scientific notation is a means of managing extremely large and extremely small numbers. So go ahead and fill in those blanks right in the page. Extremely large and extremely small numbers. Well, what do I mean by that? Well, let me just give you an example. Here are a couple of actual numbers that you will encounter in this course. That is the mass of the Earth, in case you're interested. Okay. Here's another number that you will encounter. That is the universal gravitational constant, otherwise known as G. Now, good luck loading those numbers into your calculator, especially if you have to multiply them. Good luck, Chuck. So instead, what we're going to do is something like this. And that's going to work a hell of a lot better. Those are the kind of numbers that we're going to deal with in this course. So we need to get up to speed with converting this into this, this into this. All right. It's based on an understanding of basic algebra and the decimal system. and you see that asterisk there. And you go further down the page, you see our friend Oog the caveman. Why is he there? Well, you're in college now, so now it's time to learn some stuff that you didn't learn in grade school. Who invented the decimal system? Well, it wasn't Dewey, that was the library guy. The guy who invented the decimal system is our friend Oog, the caveman, who you see there toward the bottom of the page. Who was Oog? Well, he was a caveman. And one morning, Oog, the caveman, woke up in his cave. Well, yeah, he was a caveman, that's where he lived. He woke up in his cave and stumbled to the entrance of his cave, scratching himself rather indelicately, because that's what cavemen did. And he stood out there at the entrance of his cave, gazing across the Serengeti, where he heard of wildebeest was thundering by. And it was that one moment when Oog, the caveman, had an epiphany, that aha moment. A wildebeest went by and Oog went, huh. And another wildebeest went by and he went, huh. And a third one went by and he went, huh. And he kept on going till he got to all of his phalanges there and looked down at his feet, which were encrusted with that which we would not mention in polite society. So he stopped there, which is good, because otherwise would have wound up with a base 20 system. We're reasonably certain that Oog was a young caveman. Why, you may ask? Well, because had he been older, just law of averages would have dictated that some critter at somewhere in Oog's life would have bitten off one or more of his phalanges, thereby rendering a base 9 or 8 system. But he didn't. He had all 10 of his phalanges, and there. Now you know who invented the decimal system. Aren't you glad you went to college? Look at what you're learning already. So we have this algebra looking thing. And this scientific notation looking thing. And we're going to cheat a little bit with our definitions, which is fine, as long as you cheat the right way. See, I come from naval aviation. And we have a saying in naval aviation, if you ain't cheating, you ain't trying. So, here's how we're going to cheat. There's a one-to-one correspondence with these pieces and parts. What are these? Well, those are exponents. That's a base. And for our purposes here, we'll call this the base. And this is a coefficient, and so is this. And the reason I bring this up is because the same rules pertaining to bases, exponents, and coefficients in scientific notation also apply in algebra. We work them exactly the same way. And I got a $20 bill that says that when you were taught scientific notation, they didn't teach you that it works the same way as algebra, but it does. And that's important. So we're going to redefine, we're going to use the Vince Lombardi method and redefine what these pieces and parts are. So what is a coefficient? In cheap, sloppy language, it's this. How many you got. Don't make it any more complicated than that. That's all a coefficient is telling you, how many you got. What's a base? That's what you got. So, what you got? X's. How many? 3. What you got? Tens. How many? 3. What you got over there? Ducks. How many? 3. Chickens over there. How many? 3. All right. You're just counting ducks and chickens. That's all we're doing here. Okay. How many you got? What you got? Don't forget that. Now, here's the important part, because this is what fouls up a lot of students, is the exponent part. Now, I don't care if you're already graduated from MIT with a math degree and you're just taking this course for grins and giggles. Whatever definition you have for an exponent at this point, I want you to throw it in the trash can and forget about it. For the next 16 weeks, we're going to have a different definition for an exponent, and this is the one that's going to get you through. It's an instruction. And as we used to do in the Navy schools that I went to, when the instructor stomps, that means that's heap big important. Don't you forget it. An exponent is an instruction. Remember that above all other things. It's an instruction. All right. Page 2. We'll pause here and go to page 2.